Hi everyone, we are from S3G9. I'm Sunjang and now we are going to present the case study on material selections in manufacturing of hip implant. In recent years of medical industry, hip replacement surgery is one of the most effective procedures to remove painful and replacing parts of hip joint. It is designed to improve discomfort and mobility commonly associated with the damage by any hip diseases. Hip implant consists of femoral stem, femoral head, which is known as ball, linear, and acetabular shell, which is also known as socket. All of these have their own unique features like dimension, shape, and material. So, the hip implant has to be taught which can handle the weight of the body and perform better working motion for the patient. According to the research, the materials commonly used in hip implant are titanium, stainless steel, and cobalt chromium alloys. They have to biocompatible which suitable for the body and strong enough yet flexible for daily movement. Next, I will pass to my friend for the discussion on material selection.
Hi everyone, my name is Yang Seng Hong. So I'm going to talk about the material selection strategy here. So it consists of 4 steps, which are translation, screening, ranking, and documentation. So the first step is the translation. The function of implant is to restore the mobility and relieve pain of the patient. The objective is to maximize the fracture toughness, minimize the mass and the cost. The constraint is lightweight, corrosion resistant, good to resist fatigue failure, and has to be biocompatible. The free variable is the choice of material and the manufacturing process. So the next step in the screening part, we have to derive the material index equation. The equation 1 is to minimize the mass, and the equation 2 is to maximize the fracture toughness. Then we substitute the equation 2 into equation 1, and then eliminate the free variable in the equation. Hence, we get the performance index rho over k and the material index m equals to k over rho. Then we can plot the graph in the CES software with m slope equals to 1. Then we choose the 5 material from it, which are commercially pure titanium, titanium alloy, stainless steel, cobalt chromium alloy, and the nickel-based super alloy. So this table is the property and performance of the material candidates that we choose from the graph. We will use this table in the ranking step. So based on the previous table, we will rank the material from 1 the worst to 5 the best. So finally, we will get the stainless steel have the highest score. So we can say that stainless steel 316L is the best performing material for the hip implant. So the last step is the documentation. Stainless steel are alloy of iron with chromium, nickel, and often other elements. The alloying transmits plain carbon steel that rusts and is prone to brittleness below room temperature. Indeed, most stainless steel resist corrosion in most normal environment and they remain ductile to the lowest of temperature. Next, I will pass to Philip for the manufacturing process.
Hello everyone, I'm Philip Patrick, and for today I'm going to talk about the manufacturing process and the flowchart production. For the process, we can come out with 3 types of processes: the shaping, the machining, and inspection. Okay, for now, first we need to select the raw materials. After we have selected the raw materials, we need to design the mold cap by using AutoCAD software. After we design the mold, we need to melt the raw materials. Then for this part, we need to make sure whether it's perfectly melted so that we can proceed to the next step. After we have melted the raw materials, then we can follow by the investment casting. For investment casting, it's better to making sure whether it's perfectly shaped. Only then we can move to the next step, which is the machining process. The machining process comes up with 3 types of machine, which is the CNC milling, CNC turning, and grinding. So the components are going through with this machining, starting from the milling, then proceed with turning and grinding. After we have done with all the machining, then proceed to the next part, is the inspection. So inspection plays a crucial part in this process, whether we have perfectly manufacture all the components that we are going to do. So after we've tested the components, then we can straight away to the packaging, then after the scan, and straight away move to the warehouse. Thank you.
Hello, my name is Ambrosius Herman, and today I will talk about manufacturing process selection strategy. For the first process, we choose shaping process. There are 2 stages of shaping process, which is the first stage is casting and the second stage is machining. For the casting, we choose investment casting because it fully meets the requirement in the constraint. And for the machining, it helps us to minimize the tolerance, so the process that involved for the machining is turning, milling, and grinding. The second process of hip implant is joining process. The function of this process is to join the femoral stem and femoral head. To achieve our objective, our group chose taper process. It is because we can use turning machine to crack the thread at the neck of the femoral stem and at the femoral head, so it can be joined easily without using more process and more cost. For the final process, we choose sandblasting because it can fulfill our objective, which is maximize the endurance, so we can use this hip implant longer than usual. That's all from me. Thank you.
Alright, the next one is presented by me, Minishwaran Bhaskaran. So my topic here is the effect of parameters on the performance of the product. So there are actually two categories, which is the material properties and the process parameters. So let's look at the first one, which is the material properties, and it has impact resistance, weight, service temperature, and durability. The impact resistance must be high in order to provide a better protection, and the weight, the product must be either lightweight. Meanwhile, the service temperature, it must have a high maximum service temperature to remain in function in a hot workplace. And the durability, for example, the femoral stem longevity relates directly to its durability, which means the more durable a femoral stem is, the lower the cost per wear. So it makes sense to consider the component. Next is the process parameters. So it has material, tolerances, economic bed size, the thickness, and the surface roughness. The material must be well specified. For instance, milling and turning process is used because it's compatible and meet the design requirement. The tolerances, this is very important because they will determine how well the part will fit in the final piece. The economic bed size influences how much the product must be produced and sold. And the next is the thickness. In the case of femoral stem, the large thickness is not required. And the last one is the surface roughness. In this application of hip replacement, the part should be smooth as possible for the convenience of the user. Thank you.
Hello, I'm Brandon Stepuja. I will continue the next slide. Okay, for my part is testing and quality control. For this femoral stem, it use ISO 72064 and 2010. It is to determine the endurance property of the stem femoral components. In this ISO, it's also to describe how the specimen is set up for the testing. Okay, next for the next slide is all about construction requirement. So we can see these two pictures that include all the requirement of the femoral stem and the femoral head size. So it's a guideline how to choose the right size of the femoral to be assembled. Okay, and then for the next slide is about performance inspection method. There is four testing that to apply for this femoral, but I want to highlight that the femoral fatigue testing. Its testing is undergo different heat treatment, have plasma coating applied, and have other potential stress riser present depending on the design of the stem. It will usually show up as a fail if the process of manufacturing is not performed correctly. Okay, that's all for me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Suzana binti Muhammad and my number matric is B0518101154. Type of defect. There are three types of defect, which are fracture and shatter, weight debris, breakage and failure. For fracture and shatter, according to the Ger and Nell, most periprosthetic fracture defect occur around the metal. This defect may cause the stem implant to be loose and the bone around the implant stem to be broken. Next, the defect is wear debris. This happens when materials in contact with each other with different mechanical properties. Lastly, the breakage and failure, a dangerous condition where the ball and socket of the hip implant, which consists of metal parts, abrade against each other then allow chromium or cobalt to penetrate the bloodstream. Countermeasure to avoid defect. It can be true by consideration of design and geometry. This can improve axial and torsional stability and retain maximum cancellous bond in proximal region. Next, integration distal fluid into the stem design during stem insertion. It can increase the stem rotational stability. This will also help to reduce tension of distal stem. Lastly, artificial biomaterial. Titanium is most favorable for material selection of hip implant part. The bioactive coating are to enhance titanium-based implant addition to the existing one.
Now come to the conclusion. So throughout the case study, material selection strategy is used, which the four steps, translation, screening, ranking, and documentations are applied. So the most suitable material for hip implants is stainless steel because it has high fracture tolerance and high corrosion resistance. Next, a flowchart about the production process is also developed. After this, the manufacturing process selection strategies is also used. So the appropriate processes selected are investment casting, milling, turning, grinding, and finishing sandblasting. Then, lastly, the parameters, quality control, and the types of defects and countermeasures are also investigated and determined throughout the case study. So that's all from our group. Thank you.